Hello everyone. Today I will be talking about report 3. My name is Abrar Labib and my student ID is 7885030. So today I will be talking about the differences between washing and extraction. Liquid-liquid separation is a method to separate two immiscible liquids, such as organic layer and aqueous layer. This is a very fast process in order to separate two immiscible liquids. This process consists of two parts, washing and extraction. First, the sample needs to be dissolved in a suitable solution. Here, the suitable solution is ethyl acetate. Then, water is added in order to remove all the impurities that is present in the sample. Washing cleans the dissolved compounds from contaminants. After adding water, the funnel needs to be shaken well in order to remove the impurities. Caution. While shaking, we need to be very careful and be sure that the stopper is closed and it is not pointed towards anybody in the lab room. The shaking builds up pressure inside the funnel, and we need to release the pressure gradually. The process is conducted several times in order to remove as much impurities as possible. So I will be talking about extraction now. Extraction, pulling the desired compound from one liquid phase to another. After the washing is done, the funnel needs to be kept in a resting position so that the liquid can separate, as you can see in the diagram. So in the diagram, first you see that the water is added in the funnel and then shaken, and then the layers, and then the funnel is kept in a resting position so that the layers get separated. Here, the organic layer is on the top because of less density. So after the organic layer is collected, the organic solution needs to be removed. The organic solution may contain excess water. By adding drying agent, we can remove the excess water. So let's get started with question 2, purifying the components of a mixture. So as you can see that the mixture consists of 3 compounds, the first compound, second, and third. So here are the properties also given. When water is added to the first compound, it is insoluble in water. With the second compound, it's slightly soluble. With the third one, it's completely soluble. When acetone is added, the first one, there is no change. The second one, insoluble in acetone, and the third one is soluble in acetone. Compound 1 is not soluble in water, whereas compound 2 and 3 are. So first we need to separate compound from the mixture by using a water as a solvent. Compound 2 and 3 will dissolve in water, then we can separate it by the process of vacuum filtration. Let me just describe the entire process of vacuum filtration first. As you can see, there is a butcher funnel. We need to have a filter paper and we need to make it moisturized by using water. Then we're gonna place the rubber bung so that when we're gonna put this butcher funnel in the butcher flask, it doesn't move. Then we are gonna connect the rubber tubing so that we can use the vacuum. So we are gonna slowly pour the mixture in it, and here we will get the filtrate. Compound 2 is soluble in acetone, as I mentioned earlier, whereas compound 3 is insoluble. First, we add acetone in the mixture and compound 2 dissolves, and we can easily separate by the process of vacuum filtration, as I mentioned a few minutes ago. So now we are left with a mixture of water and acetone and compound 2. we will be using evaporation technique in order to collect the pure compound 2.
So I will be talking about question 3A right now, which is about the organic synthesis. In order to perform this organic synthesis, we need to follow a few precautions, like we need to wear our safety goggles, gloves, and our lab coat all the time, as we are going to handle some toxic substances such as 2-naphthol and 4-iodobutane. So first, where 0.5 gram of naphthol is added, which is brown in color, then we're going to add 3 pellet of NaOH, which is white in color. 5 ml of 95% of ethanol is added into the distillation flask as well. As you can see in the diagram, with the distillation flask, there is a condenser attached, and it is also covered with a plug. So before the boiling, the color of the mixture is kind of off-white. Then gradually when it starts boiling, it turns brown. After the dissolving of solids, 0.5 ml of iodobutane is added. The refluxing needs to be connected for 1 or 1.5 hours. The sample needed to perform a TLC. TLC is conducted just to make sure whether the reactant is present in the final product or not. In order to form the crystals, the solution is set in an ice bath. Ice bath reduces the temperature of the solution and helps to form the crystals in a faster pace. After the crystals are formed, we can use a spatula to collect the crystals and put it in an ice glass. There might be still water present in it, so we can actually put it in a microwave, and if it's not available, we can actually press it against filter paper to take out the water out of it. In order to form the crystals at a faster rate, we can put the solution in an ice bath. Ice bath reduces the temperature and helps to form the crystal at a faster rate. When the crystals are formed, we can use a spatula to collect the crystals from the flask and put it on a watch glass. There might be still some moisture present in the crystals that we got. We can take the moisture out by putting it in an oven, and also we can also try taking the moisture out by pressing it against filter paper, and this is how we will get a dry crystal. So I will be talking about question 3B, which is the analysis of the product. So how can we analyze a product? We can look at the physical properties as well as the chemical properties. So physical properties are given here as shown. 2-butadioxynaphthalene is highly soluble in organic solvents and also non-polar in nature. As you can see, the physical properties mentioned, melting point is in the range of 31.5 degrees Celsius to 32 degrees Celsius. Boiling point is 315.3 degrees Celsius, and chemical formula is C14H16O. Since you can actually see this, it is a covalent compound. Molecular weight is 200.28 gram per mole. It is solid in nature and has a creamy color.
So now I will be talking about the last part of question 3, which is question 3C. Here, we will be talking about the synthesis of 2-butadioxynaphthalene. The nucleophile can attack the partial carbon from only one side and can form only one type of isomer, which can be a D isomer or L isomer. The third the third reaction, in the third reaction, we deprotonate 2-naphthenol to give rise to a strong nucleophile. The nucleophile then attacks the substrate, which is 1-iodobutane in the second reaction. And with this attack of nucleophile, the leaving group iodine is simultaneously ejected off the substrate, generating the desired product, which is 2-butyroxynaphthalene.
So now I will be talking about the last part, which is question 4, techniques taught for purifying and characterizing organic liquids and solid. So first of all, I will be talking about recrystallization. Recrystallization is used to purify an impure compound in solvent. So actually we dissolve the solute in a solvent completely, and then cool the solution. When the crystals are formed, we take it out with the help of a spatula on a watch glass. Then to remove the excess amount of moisture, we can put it into an oven to dry it down, or we can actually press it against a filter paper to remove all the moistures present. So I will be talking about melting right now. This determines about the purity of the crystals formed. After getting the crystals, the melting point is checked just to check whether it contains any impurity or not. If there is any impurities present in the crystal while conducting the melting point determination test, the melting point will rise due to the presence of impurities. We can also determine and identify of the crystals by using melting point determination. So now I will be talking about thin layer chromatography. So the vertical chromatography paper is taken and a baseline is drawn on it. The solution containing the mixture of pigment is placed over the baseline with the help of a dropper and allowed to dry. The paper is then placed in a beaker containing the chosen solvent. As the solvent travels up the paper, the pigment separate out according to their solubility. Higher the solubility, the more distance will be traveled by the solvent. So after that, a front line is drawn which represents the distance traveled by the solvent. So we can find out the RF value and we can actually determine whether there is any reactant present in the final product by conducting thin layer chromatography. I will be talking about gas chromatography as well, which is quite similar to thin layer chromatography. Gas chromatography is basically used to test the purity and identify the different compounds in a liquid. Now I will be talking about distillation. There are two types of distillation: simple distillation and fractional distillation. In simple distillation, it is the process to separate solvent from a solution using evaporation followed by condensation. When heat is applied at 100 degrees Celsius, water starts to evaporate. The vapor entering the condenser liquefies, condenses, and collected as distillate at the temperature range of 100 to 104 degrees Celsius. And the salt particles will left behind in the flask. Function of condenser, which is used in both fractional distillation and simple distillation. The running cold water in the outer jacket of the condenser absorbs heat from vaporing passing through the inner tube of the condenser and convert it to a liquid state. Now I'll be talking about fractional distillation, separating two or more miscible liquids according to their boiling points with the help of fractionating column. This process includes evaporation and condensation. For an example, separating of ethanol and water. When heat is applied to the mixture of ethanol and water up to 78 degrees Celsius, vapor of both liquid move up to the column. Water with higher boiling temperature will condense and fall back into the flask, whereas ethanol vapor continues to move up the column, enter the condenser, and liquefies and get collected at a temperature of 78 or 82 degrees Celsius. The upper portion of the column is cooler than the lower portion. For this reason, the vapor of the liquid with higher boiling cools down in the upper portion and falls back into the flask. The temperature gradient in the column enables successful separation of miscible liquids. Now I will be talking about washing and extraction. Washing cleans the desired compounds from their components, and extraction pulling the desired compound from one liquid form to another. Now I will be talking about the IR spectroscopy. IR spectroscopy is a useful tool in analyzing the purity of a sample and also deducing the identity of the unknown compound. IR spectroscopy measures the amount of light, in particular the light from the IR region that transmitted through the sample, and also measures the vibration of atoms. And based on this, it tells us the functional group of the molecule present. So the last one is rotary evaporator. Rotary evaporator is a useful substance to remove a volatile substance from a liquid mixture.